In the entire universe, we know with certainty of just one place that is teeming with life: Earth. Separating life on Earth from the rest of the cosmos is our atmosphere, a thin layer of invisible gases surrounding our planet like a blanket. When fossil fuels like oil, gas, and coal are burned, releasing carbon dioxide molecules into the atmosphere, this blanket traps heat that would otherwise escape. This blanket effect is warming the planet and disrupting the balance that keeps our climate stable. Carbon dioxide molecules can stay in the atmosphere for centuries, slowly but steadily warming the planet. The natural world plays a critical role in slowing climate change. Every year, about half of human-caused carbon dioxide emissions are absorbed by oceans and the world's vegetation, including crops and trees.
Carbon is an element that's in the air, mainly as carbon dioxide. Trees consume this carbon dioxide, they eat it as food, and they store it as wood. And 50% of what you see in a tree in a forest is carbon.
And that's carbon that, if it weren't in the tree, forests were cut down and the wood decomposed, that carbon would end up back in the atmosphere as carbon dioxide.
And it's by measuring trees over the long term, we can actually detect these changes in carbon and biodiversity.
We want to get a global picture of the amount of carbon that's stored in forests. And so what we're doing in GeoTrees is building a global network that maps, monitors, and measures forest carbon, and making that available to the world.
NASA, using airborne and satellite data, also looks at how forest changes impact carbon dioxide concentrations in the atmosphere. With these data, we create sophisticated models and data sets that help us track how carbon moves through the atmosphere, land, and oceans. Together, we are getting a better understanding of the global carbon cycle. Covering the world 24 hours a day, 7 days a week, NASA collects data on carbon dioxide concentrations and forest ecosystems. But with all of this data, there is still more to learn.
Forests look different from space, essentially from satellites. So it's really important to have data that spans this range of variation across forests if we're going to be able to build good models to predict forest carbon from satellite data.
The core idea of GeoTrees is to provide this biomass reference system for forests globally. That reference system is extremely valuable to the Earth observation community for calibrating and validating their Earth observations from satellites. It's also a really important baseline for monitoring change in forest carbon stocks, modeling the future of forest carbon stocks, for carbon markets where individuals, countries, jurisdictions want to quantify the amount of carbon and therefore carbon dollars in their forests.
Para la parcela permanente de Macayaco es importante hacer parte de una red global de bosques, primero porque nos permite comparar los resultados que tenemos en nuestras investigaciones con muchas otras parcelas a lo largo del mundo, muchos diferentes ecosistemas, porque sabemos que los métodos de medición son estandarizados.
The amount of carbon dioxide in our atmosphere is increasing and warming our planet. Ground-based measurements are critical for demonstrating to communities all over the world that they can rely on satellite data in their decision-making. This data is free and open to all so that everyone, researchers, businesses, governments, can make informed decisions to better manage our resources for this and future generations.